question 8. So for part A, find the value of the car when t equals 0. So find v when t is 0. Well, t being 0 is going to make each of these powers 0. Anything to the power of 0 is 1. So 17,000 lots of 1, 2,000 lots of 1, add 500. So adding those three together we get 19,500. Now for part B, we've got to calculate t when v is 9,500. So 9,500 on the left, all of this on our right. So let's start off by taking away 500 from both sides and then dividing by 1,000. Now it is awkward to be dealing with e to the power of negatives. So let's try and undo the negative by choose to multiply through by the biggest negative we have here, which is e to the minus 0.5t. So let's choose to multiply all three terms, 1, 2, 3, by e to the 0.5t, giving us this. Now we have, if we take all of this to the left hand side, we can then really create a quadratic, because e to the 0.5t is e to the 0.25t times 2. So we're going to so this is effectively the y squared, this is the y, and this is the normal number. So here's our quadratic. So factorizing this, we get this, and so our solution, we would need this to be negative to make this bracket 0. You can't get a negative when you've got your variable as the power. So in order for us to, when we multiply these together to get 0, we need this term to be 0, the whole bracket to be 0. So e to the power of 0.25t has to be 2. So we have our 2 take over 2 is 0, 0 lots of whatever is 0. So e to the power of 0.25t equals 2. So if we learn both sides and then follow the power rule, we get 0.25t ln e equals ln 2. Ln e is 1, so 0.25t equals ln 2. Multiply both sides by 4, we get t being 4 ln t. Now for part C, we've got to find the rate at which the value of the car is decreasing at the instant when t is 8. So rate of change, so we need to differentiate. So we need to differentiate v with respect to t to find dv dt. So how do we differentiate when we have powers like this? Well, when it's e to the power of something, we the differential is the minus 0.25 to the t. We have to differentiate that and bring that down to multiply it by at the front. So we're going to have 17,000 times the differential of minus 0.25t, which is minus 0.25, and e to the power bit stays the same. Same with this second term. When we differentiate this, given it's to the power of e, we multiply the 2,000 by minus 0.5. So 2,000 times minus 0.5 times e to minus 0.5t still. So with a calculator, multiply these two together and multiply these two together, gives us this, and we're going to substitute in when t is 8. So substituting in when t is 8, so this times this is minus 2, this times this is minus 4. So this is what we have to solve. So popping this into a calculator, we get minus 593.49, or 593 to the nearest pound.